Okay, hello. This tutorial is sort of ad hoc, so not very well planned. I hope that it will make sense anyway. This is about making one object control another with float expression. So it's an alternative to wire parameters, and to me this is much better option. So I have now this old rig that I barely remember how I built it, but I just put a keyframe for the steering wheel object, which is this. So if I spin it, the wheel spin, and it like a correct car, the outer one spins less, which is easy to create with expressions. And I also have a like car banking control on this crosshairy thing here. So if it's braking, or if it's accelerating, or if it's coming to a turn, you can bank it. Yes. And I might make it so that when you move it up and down, then the body moves up and down. So basically I want that dummy to follow it, and maybe with some kind of multiplier, so that these movements of these are bigger than the body, so it's kind of easier. That's often you might want to do it like that. So let's get going. One more word. I use spline objects. So these objects are actually splines. It makes it easier to filter certain things, and then dummies are a bit silly because they all look alike. So if I hide this, you can see that where there's all those ball joints, there's like a lot of overlapping dummies, and it becomes quite a mess. So they are definitely not ideal. Even changing color is tricky on dummies. It's such a silly thing. Okay, but let's get going. So curve editor. How do I make this thing to rotate that steering thing there? This is that steering thing. Kingpin steer. Kingpin is the axle around which the steering rotates. And the top joint is sort of, so one end of the axis is the upper ball joint, and the other is the lower ball joint, and that's kind of around what the rotation happens in a real MacPherson strut suspension. So this is the object. Before I go there, how the actual controller is made. This one is parented to an object that is in the same coordinate space. So let's look at these. It's important that they share, like in the neutral position, they share exactly the same axis. This makes it so much easier, and it's actually kind of a requirement, because otherwise, if on a base position this was, I have already locked it, smart guy, so that it doesn't look like I've locked it. Well, for some other reason it's not working. This is an old rig, so who knows what I've done. But you need the object to be parented to an object in the same orientation. Otherwise, you can't control the Z rotation, for example, in this case, to go just around that point. I actually didn't have the rotation tool active. That's why I wasn't able to rotate this thing, I think. No, it just doesn't want to rotate. It has a look at controller. That's why, because it's looking at the top one. Okay, but this is parented to an item in the same orientation, and that's the key, so that I can isolate the axis correctly. Now, the controller that came from the steering wheel, let's still make the selection so that it's logical for us, or that we have only these selected and showing. It would be the Z rotation I'm controlling, and if you are creating a new one, you go assign controller and you select float expression. Now I already have the expression there. We're going to create a new one for the other function, but I'll show you here. And then if you right click and go to properties, you see the expression. So what's going on here? Ackerman is a constant that I'm using in the sort of the expression. We can ignore it totally for now. Basically, Ackerman steering is the effect that the inner wheel goes around smaller curve than the outer, so then you can make it so that, or I'm making it so that the inner wheel turns somewhat more than the outer. So this is just a multiplier. It's a multiplier of 1.5, and it's assigned to constant 1.5. So, and then this is the key, the steer. I have created this controller, and you can create a new one. You just need to point it to an attribute, to another controller that you want to drive it. So the steer, for example, is pointing to the steering wheel rotation controller Z rotation, which would be this guy. So let me now break it for a second. I'll do the edit hold thing so I can come back. That thing is locked, so I'll make a copy of it, and I'm gonna call it Berta. It's the B. So now assign to controller, and then I'm going to select objects, and I'm going to select the Berta. Now when you have all the objects visible, like if they are all unhidden, this is quite a mess, because it's going to be the whole hierarchy that you can find the object. So actually hiding or isolating the object that you want to work with is very smart. So here's my Berta, that's the object. Now under transform, I can find position, and now I'm gonna bind it to the bezier of X movement. Now I change this system, so now it's gonna be, I'm gonna have to unlock the X movement too. Now it's the X movement. I replaced it, so now it's the X movement of this object that is driving the steering. Wheel, and those still visible, so then it's more interesting for us. So now it goes around a lot. Let's change it back to this guy, which was the steering wheel. Steer assigned to a controller. This is, by the way, colored now because it's selected. So I'm going to go and select transform, rotation. By the way, you do want to use the Euler XYZ so that it gives you the isolated axis on both the object that is rotating, that you that you want to steer, and the driving object, which is the steering wheel. Now we should have it back as it was. So basically now we have this value steer that is tied to the rotation of this guy. So then here I write my expression. I'm gonna Control X these and just type steer. Now if I hit evaluate, oh, this is capital cap sensitives. So if you're gonna use capital, you're gonna have to use it here too. Now debug is how you get a screen where you see the solution. So now if I rotate, you can see that there's a number going on. So now it keeps the exact same rotation. Nice. Now why did I have such a complex formula here to begin with? Well, this was because of the Ackerman steering actually. I was just doing so that if it's more than 0 or less than 0, then you divide it by Ackerman, or if it's else, then it's steering times Ackerman, and the Ackerman constant for me was 1.5. If I wanted to change it, this is how I've done it. Now I can change it to 1.2, and then the Ackerman effect is bigger. One thing with the rotations, it doesn't matter now because I'm driving a rotation with rotation. So it makes sense to me that if this turns 90 degrees, the lower one is going to turn 90 degrees also, if we ignore this. But they use radian angles. So you can see all the function list here. I'm a bit jumpy, but you want to expose sometimes the rotation instead of radian. You want to express it as angles, or vice versa. You want some x movement to translate to rotation, and then you think that, well, this goes up 5 units. I want it to equal 5 degrees. Well, let's pretend now that the steer is pointing to a z movement of the steering wheel. Instead of just putting steer and expecting that this moves 5 degrees and this 5 units, that this would turn 5 degrees, well, it's not going to happen. Actually, we can do that. Can I actually? There probably would be some kind of way of deactivating these, but I'm going to just copy it and put it into Notepad. Yes, I know I'm jumping all over the place. I'm sorry for that. So let's point this Aukerman to the Z movement of this guy. Let's first see that it can move up and down. Yes, it can. I mean, this guy, assign to controller, steering wheel, position, Z. Okay. Evaluate. Always uses the parent yeah, that's kind of good to understand actually. When you tie this to a value, it's gonna be how far is this from its parent. For example, now it's if we look at the world coordinates, this guy is at, oh, what am I doing? This guy is at it's at 166 centimeters from the Z. Yet the steering value, the, what do you call it? Not multiplier. I'm not English speaker if you haven't figured it out yet. What do you call it? Scalar. Well, what an x is in a function. Anyway, the steer value is 0 because this thing's value in Z is 0 in parent space. So it's linked to an object that is in the same Z value as this guy. So if you're going to use some other object and then you to drive something, and then there's a weird pop or a thing goes into weird place in space, if you're using it to drive X, Y, or Z, it's probably because your driving object is not actually zeroed in relation to its parents. But all the values that we're going to be using, like the rotation or whatever, they are always measured from the parent, and that's good to understand that any kind of animation curve, whatever, it's always measured from the parent coordinate system. So anyway, what I was talking about was the radians, and how now if we move this, let's go to we'll ignore the rotation and we'll go and move this up 5. Now then you think that, oh well, this guy must be rotating 5 degrees. That thing that actually rotates, which is this guy, and you look at what's this madness. It's not rotating 5 degrees, but it's rotating 300 degrees. What kind of business is that? It's rotating like crazy. Well, because it's 5 radians. The expression value is it's 5, but the rotation is 5 radians and not 5 degrees. So if you wanted it to turn actually 5 degrees, you would have to write degrees to rad. And then close. And now, if we go and check the rotation in the parent space, at this point, it's 5. Just like we move this up 5. So if we move that up now, let's say 15, or let's make it uneven 17, and then we go and check what's the rotation. Now it's gonna be 17 degrees. So important to note, it's small, non-capital D, capital T, and capital R. So sometimes you need to do these things where you change the degrees to radians to get the thing where you want it, when your input was a numeric value that you think as degrees, but then you want to translate to radians for the rotation to understand. And sometimes you have to do it the other way around. So then that command would be rad, oops, again, not capital, to not very good. So you can go back and forth, but when you're doing math, sometimes you have to go back and forth. So this is good to understand. And then you can do all kinds of functions here, not complex scripting, but you can do set maximums and minimums. So if you had like 2 values, you could set that if use A or B, or use whichever is the bigger one, and things like that. If I remember right, I think that there is like a max. So it uses the maximum value of x, and y. So whichever is bigger is going to use that. So this is kind of sometimes nice. So you can use that. For example, you can set the limit so that it always uses my variable input unless it's smaller than 2. So then you're going to get kind of set a limit with the 2. If you put this is the variable input and this is 2, max, oops, max, I think it was without capital, steer 0.2. Let's do that. But then I need to do the dig2 rad. Now it's going to use degree to radian. Okay, it's just going to convert it, but then it's going to use the steering. But at least it's going to use 2. So now if we go to 0, the rotation should be evaluate 2. Evaluate is needed to update. If you change the expression, you need to hit evaluate to update. Otherwise it would error all the time when you're typing. It only updates when you hit there. So now it's 2 until I turn. Whenever it gets bigger than 2, then it starts using the steering. So there are a lot of kind of nice functions here. Simple if stuff is often good to use. Then you have pi, you have the trigonometric stuff if you need those. Smallest integer, yeah, you can use integrals. Of course, I don't use very many, but then of course sometimes you might need square root or things like that. And then it's also good to note that there are these certain words or expressions, variables you can't use yourself because they're already reserved. Like T is ticks, F is frames, S is sex, NT is normalized time, whatever that means. I don't actually even know. But you can use those for forming your expression. But now I'm just gonna put this back so that it's my system is intact. Now close. It's all messed up. Why? It's all messed up because my expression is pointing to the wrong thing. Properties, because I was making that that example of tying to a different thing. So I'm gonna tie it to the steering wheel, Z rotation, boink. Let's kill that movement because it looks funky. Okay, so now let's do that fresh for the Z movement of the car body. And then maybe repetition is good, and then at least we'll do a new one here. This is actually a good example where this thing now is parented to that. So we might want to check what's the position in the parent space. So it's -72.6. So I'm gonna actually put that on Notepad, though we don't really need it, but I'm gonna put it there. So open curve editor. We're gonna want to make it so that this control bank, it's gonna be control bank and bump, because it's gonna control the bump too. So let's go to here. So Z position is what we want to drive. Right click, assign controller, float expression, boink. Now it comes here. Now this is what its current value is. So it's what the thing that I copied that I wanted to store the difference here is written here. Let's keep that in back of our heads and ignore it for now. Then we're going to create a variable which is Z bump. I know that sounds like a texture thing, so let's just call it body lift. Create. Now it's by default it's assigned to a constant, which is 0, but we're gonna assign it to a controller. I'm gonna select this first. Note that this thing stays open even if you select other objects. Not very 3D Studio Max like. Assign to controller, and then I'm gonna try to find that crazy thing that drives it, but to make that easier, I'm gonna do this. Screen is a bit behind its times. So it was the bank and bump. Transform position Z. So I'm tying this variable to that. And then you go over here and type body lift. Note the capitals. Evaluate. Boink. What the hell just happened? It went to 0. That's not exactly what I wanted. And it's kind of weird actually that it went to 0. Because it's parented to this thing. So it went to 0 in its parent space. That's why there used to be this -72 whatever, because it was that much below. So you would either create a parent that is in the same neutral position that it originally was, so that then you don't have to worry about it. That would be preferable, but I'm just gonna do it like this. Now it's in its original, because I stored that value. It's the same value that was here visible before. So now I'm gonna do all my expressions. Oops, the minus belongs with the number. I'm gonna do all my expression, and then I'm gonna always drop it by that much, and then it's where it used to be. So now if I take this thing up here and move boink, 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 now the body moves up and down based on the movement of this guy. And the benefit here is that I can do it so that it's 1/4. So now I can move this more, and the body moves just a little bit, which is sometimes nice when you're animating, that it's kind of, your controller is doing more exaggerated movement than the actual thing. So it's kind of easier to see, and you get sort of more fidelity from it. It was that simple. we could, instead of the 0.25, we can create a constant which is control multiplier, but I'm saving time here. Assign to constant, and I'm gonna put 0.25. So now I can use the variable before instead. Control multiply. And then if I had a spelling error, then it's going to give me an error. So now this thing controls the bump. Simple as that. Now, then if you copy objects, it's a good question actually, though you didn't ask it, but I kind of started thinking myself. I can't remember. Ctrl V, copy. Close that. Body lift. It's following the copy. So basically what I was testing, if you copy an object, if I copy just one object, let's say that I copy just this thing. It's gonna keep the controls from this guy. But when I copy both the controller, the controlling object or the driving object and the drivee, the one being controlled, then it's going to update the controller to those new objects. So if you copy a whole hierarchy, it's going to keep the logic within the hierarchy. If you just copy one object, it's going to keep pointing at the origin. So it's actually nice and a logical way of handling that. Not always something that you should take for granted. Now this car also has another benefit. This is end of the float expression tutorial. Using an expression to drive the steering, the wheel rotation works fine as long as you move along, let's say, y-axis in my example. It's fine. I could use just a simple distance from wherever and then drive the tire rotation, and it would work just like this. So that it's always perfect. But it would totally break when, if I did this and actually animate it in this direction. Because now it would take the X direction, X travel, which is from here to there, and rotate based on that. And that's very different distance than going from here to here. And it's especially true if we were, say, going here. Now we are barely moving along the, Y, G, whatever they are in the world space. Yeah, Y. We're barely moving on the Y. We're only moving here, so yet this rotation works. So I have used tire rotation script. I will see if I find link to that exact script that I used. But this works even if my car was doing oops, wrong controller. If my car was doing some kind of a loopy loop. Now this is obviously totally poopy route. I can't talk and click at the same time. Let's move that away. And we are somewhere here. this is just a demonstration of the tire spin, not the sensible animation. And by the way, it's a really bad idea to have the whole vehicle's root pivot point be there. You would want it to be somewhere lower. Wonky coordinate system. But now you can see that it's spinning the correct speed. I trust that it's exactly correct speed because it's using the script control. Anyway, you can't do it effectively just with a wire parameter or what should I call it, float expression. And then you might think that, well, I'll combine the x, y, and y, and then I'll calculate it. But it's still just a distance from there. When you start going back and forth, then the tires would spin back and forth, and it's just going to be a mess. You have to do a thing that compares the position on this frame and the previous, and then kind of cumulatively does the rotation. That's the only sensible way to do the tire rotation. But there are scripts for that. End of video. Hope this helped somebody. It certainly worked for my procrastination, so that I'm not working when I should.